Last time it was, a little bit more on objects, and we're just going to carry on from there. I think we landed with the toString. So, there we go. Yeah, so toString, in many programming languages, this is going to be a really special function. And so we're going to write this special function for our student class, and it's going to mean like, well, if I ever tell a student object to toString, it'll return some string representation of what that student object is. But do note that what the string is that we return is entirely up to us. I could make the student's toString return like just a random number. I mean, that's not going to be very useful, but I could do that. But here I'm using it to just, oh my goodness. How bad is that saw sound? And I'm hearing a lot of boops. What do we got here? Can't read the code. Very blurry. Well, it shouldn't be that bad. A bit better. I'm wondering if it's just internet speed issues currently. Yeah, 2008 YouTube vids. Well, the good news is the YouTube video will be much better quality as it's recording directly from the computer, and it doesn't have to use how Blackboard collaborates not great compression system, but yeah, so hopefully it's not too bad. The point here is just it's the toString code, and if we look here, I mean, here it is. This is it. I'm gonna get rid of these. There. It's just creating the string, and then, we just keep building the string. We keep appending to it. And yeah, so we design it so the string is representative in some way of the specific instance we care about. More questions. We can't see the code. I know you've said that. Oh, you only see me now. Oh, jeez. There we go. My goodness. All over the place today. And again, yeah, how bad is that saw sound in the background? There's no door to even close anymore because they took the door away. Music to my ears. Well, as long as you enjoy it. Okay. And here's an example of us using it. If we created a student called Bob Smith, and we said, okay, here, print out the A student toString, and it'll print it out how we formatted it. Now, another question we want is, well, how might we want to know if two students are equal. But, I mean, we're defining the student class, so we have to define what it means for two student objects to be equivalent. The possibilities here are endless. I mean, there's an infinite number of possible ways that we can define an equality between students. We could check if their height is the same. And then we could say, okay, if their height's the same, then they're equivalent. But in this context, it doesn't make a lot of sense, right? Like, that's maybe not useful for our purposes. But the point is, we get to define what it means for two student objects to be equal. In this case, I suppose a reasonable thing to check is if their student numbers are equivalent. If you have two instances of a student that happen to have the exact same student number, they must therefore be actually the same student. And otherwise, when you're asking for an equality, we might be asking the question, well, are these two pointers, like if we have pointers to student objects, are these two pointers pointing to the exact same student, literally the one single student object? Like we have two pointers going to the same location in RAM where a single student is stored? Or do we want to check like, well, I mean, although that might be the case, but if any two students have the same student number, they are therefore equivalent. And here's the way we're going to write this. So we'll add this to our header. I'm just going to copy this, go to the code, go to my header, and add there. Bool equals student other. Now, the return type of this function is a Boolean. It's called equals. And you will notice that we now have some, like I was saying before, the use of the reference. The way we're going to use it is more of the, well, we're just going to use the magic code that we need for C++. When we want to check, when we want to write this equals function, we need to give this function a reference to a student object. Why? Because that's the way it is in C++. So what we're going to do is, okay, when we ask, like we're going to ask a student object if they're equivalent to another student object. And we'll see an example of us using this in a moment. But just to finish up the code itself, let's have a look. I'm going to go to my student CPP and add that. Oop. Okay. And there we go. In fact, do we have this? There. I like this better. So here's the code itself. Bool, okay, that's the return type. It's either going to return true or false. And also, by the way, the way I've written this, I hate it, but I'm going to explain that in a moment. And I'm asking, okay, from the student, defining equals, it takes a reference to a student, and we're going to call the reference other. What we call this is arbitrary. We can call it ASD if we want, and it's fine, but, other seems reasonable here. And what are we asking? If the current student's student number happens to be equal to the other student's student number that we get through this accessor method, the get student number, if they are equal, well then it's equal. Otherwise, return false. Now, some people in here are going to remember me from last semester saying, no. Writing it this way, this is, although absolutely correct, it's a bit of a joke that really, we want this. Okay, really, it's kind of better if we do it this way. Because what is this asking? Oh, semicolon. Well, what we're saying is, okay, return the result of this question. And the result of this question is effectively what we had before. If this object student number is equivalent to the other student number, the result of this expression here, by using the equals operator, will be true. So we will immediately just return true in that case. But if they're not the same, if this is in fact not equal, this question will be false. This expression will result in false, meaning that we return false. So we're cutting out the middleman here. So that's awesome. Great. So now we've got our equals written. This is a nice cleaner way to do it. If you like the more verbose way, it's fine. You can do it this way if you'd like, but this, is better. All right. Why did you make it a reference to a student and not just a student? Well, we kind of have to do it. And especially, if we made it not a reference to a student, if we made it like an actual student object, like if we just said student, no ampersand, other, we would actually run into a bit of a problem, because then we would actually make a copy of the student. And then, we don't really want to make the copy here. And if you don't, whatever. Now, I guess maybe in this case, we don't need to do it with a reference. I guess we can do it with a pointer. Maybe I guess it's in other areas, like in the copy constructors, where we must do it with a reference. But yeah, it does look like we can actually do it with a student pointer. In fact, I prefer it this way. So I'm going to go back and change it to the student pointer, because you know me, I like my pointers. And then the only really change I need is this. Okay, great. There we go. Problem solved. I heard a boop. What do we got here? Where did the this come from? Okay, so first of all, remember that this is a way to get access to the attributes and functions inside of a class. But when the thing over here, other, is a pointer to a student, when it's a pointer, we use this to both dereference and then get access to those things. Now, this is a special keyword that I do not need here. If I do this, this will work just fine. But I like to include this because this is a little bit more explicit. When I say this is a special keyword in C++ and many other programming languages. In Java, it's this as well. In Python, it has something that itself, not this, but it means the same idea. This is always a pointer to itself. Really, the way I would read this, and this, I remember, I didn't actually truly understand this keyword until I got to my second year computer science. So don't worry too much. But what it means is, okay, this current, the current student's student number, is it equal to the other student's student number? So this is a pointer to itself. So this is effectively accessing the current student's student number. And I'll show you an example of like where this comes up on the next slide, I believe. Yes, perfect. Here's what I'm gonna do. I'm gonna copy this. No, I'm gonna do it my pointer way. Here we go. Do I have the equals? I guess I didn't do it with pointers, but that's okay. In the slides. So I'm gonna go back to Hello World. Replace all this. So what am I doing? Oh, no, okay, this won't work because we did it with pointers. So what did I do? I created a student, then B student, and then C student. You'll see that although A student and C student, I created two students, but you'll see that they're actually like the same thing. Really, at the end of the day, they're the same thing. Both are Bob Smith, student 1, 2, 3, 4, 5, 7, 8, 9, B Smith, same effects, 89%. But B student is an entirely different one. It's Sally McLeod, okay? So there. A and C, we have two variables called A student and C student that happen to have two separate instances of student objects, but by our definition of what it means for two students to be equal, they're equal because their student numbers are the same. I mean, in fact, these don't even really need to exist because all it's ever going to check is the student number based on how I wrote it. But just to make it explicitly clear, I'll leave it like that. Okay, so when I call the equals, right, I'm saying, okay, A student, okay, this one, this is Bob Smith, 1, 2, 3, blah, 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 equals, are you equal to B student, right? So the question is A student equal to B student? In this case, here, when I call this function and we go inside the function, this will be just like the pointer. I guess it's not a point. Just like A student, you know, it is the student object. This will be a pointer to this variable. Basically what we've got here, I'm going to go back to this and I'll draw it, or at least I'll try to draw it. If we go down here, what I got here, okay, so we got A student. Okay, and inside of it we have a student because it's not a pointer the way I wrote this code. Why? Because. But then this student right here, within it, it has this like hidden super attribute called this. So this student object kind of like has this variable called this, and inside this, it's a pointer to itself. The usefulness of this right now, I'm being kind of like overly verbose in my code. The reason I like to use this in this context is because when you look at the code right here, it eliminates any ambiguity of, like when you see this, it's like, okay, student number. And this would refer to the current instance's student number, like the current code that's running, in this case here, A student. I lost my place. It's going to be A student number. But when you put this, like it becomes so abundantly clear that I'm comparing this instance's student number to the other instance's student number. Where in this case, other, when we go back to Hello World, is B student. So A student is being compared to B student here. And then on the next line of code, A student is being compared to C student. Now, I'm going to build this. And when I hit run, we should see false and true. Because A and B are not equivalent. Their student numbers are different. But A and C are different, are the same. So when I call this, A student is being compared to C student. So here in the code, as far as this code's concerned, this is like A student and other would be B student. I'm going to run this to make sure it does give us false true, as it should. Oh, okay, we saw 0, 1 really quick. Let's run it again, see if it'll, yeah, okay, 0, 1 there, false true. I could change this to this. Okay, first let me explain it this way. A student, again, will be the this, and then the other this time will be C student. I could change this to C student, and then this to A student. And it's, although computing effectively the same thing, now when it's written this way, C student is the this, and then A student will be the other in this particular situation. So this would be A student, other is the pointer to B student, or the thing B student points to. Is this similar to self? Absolutely. It's the same thing. It is exactly the same thing. It's just for whatever reason, although like all the other programming languages use this keyword, Python was like, no, I'm going to use self. And then it is what it is. Why? Because that's what Guido put. And Guido is the inventor in Python, of Python. So yes, you're absolutely right. Connecting those dots, absolutely right. All right. Okay. Don't feel bad if you don't know the answer. Okay, here. Okay. Yeah, here's a good test. A student, I create it. And then I say B student is equal to A student. And then I say, okay, B student, set first name to ABC. And I ask, okay, what is A student's first name, B student's last name? When I hit run, what should we expect? Oh, I don't think I actually wanted to keep those. Go away. Okay, don't look at the answer. I'm going to replace all this code with this. So now we've moved away from the equals. So the question I have right now is, what's going on right here? Let's build it. Look at this code. I'll zoom in a little bit more to make it easier to see. I'm making an A student object. I'm then saying B equals A student. And then I'm saying B student dot set first name to ABC. Take your time, think about this. What should the answer be? I suppose the question really comes down to, what's going to be printed out? Are we going to see Bob followed by ABC? Or are we going to see ABC written twice? That's the question I've got for you. Will both names become, since it isn't a reference? Well, see, that's the question. You can't answer my question by asking me the exact same question. What are you doing? But yeah, you have identified like the question. So what's going on here? Well, let's hit run and see what happens. We see Bob and then ABC. Raise your hand in the chat if you are like, yeah, that makes perfect sense. I'm happy with that. One person. Okay, a couple of people. There we go. Okay, cool. Now, the other group of you, I'm guessing, is thinking like, well, you know, I was expecting it to be ABC because we've modified ABC. I mean, we modified them, but we also set like B student was equal to A student. So why was it not like, you know, you modify it once? Like, why? What's going on there? Well, because what we did here, remember, right here, this isn't a pointer. And when you're thinking, like, if you're thinking like lists, well, you know, when I access and change the contents of a list through another variable, it changed it in both places. Like if you're thinking back to Python. Well, yeah, you're absolutely right. And that's because in Python, everything's a pointer. And you're not crazy for kind of expecting this to work this way. But really here, because this isn't a pointer, we've actually like in static memory created a student object. When we do this, we're making, just like primitive types, we're making a complete copy of the student object. So when I say B student equals A student, we create the variable and we make a copy of the contents. Remember, the rule is whenever you say something like B student equals A student, the contents of the variable is copied over and put inside the other variable. That's the rule. There's no trick. That's the rule. So the contents of A student, which is a student object, gets copied over in B student, and then I modified the contents of B student. I showed it by turning them upside down. Okay. Now, here's the different situation. It's almost identical code. The only difference is that, oh, I guess I didn't actually copy it. There. The only difference here is these are pointers. These are not students. I am not making a student variable, a student object, putting it in a student variable. I'm creating a dynamically allocated student object that's getting put in dynamic memory, but the variables A student and B student are not students. The contents of these variables are pointers to students. And what we have done here is, well, we copied the contents of A student and put it into B student. Let's go back here. So what I have done is, the important thing is here is, and you will never make a mistake. You will never get confused if you remember this important rule. What is in the variable? And to answer that question, all you got to do is look at the type. Whoop, nope, the type. These are student pointers, not students. So what's in here is like the arrow, or really, you know, it's the memory address of, I don't know, whatever that is. Okay? This is in RAM somewhere else. And then when I say B student equals A student, well, I make another variable that's a student pointer, and I copy over the contents of what's in here. Well, that's just the pointer to the exact same student object. I am copying over the contents of what's in that variable. I'm copying what's in RAM. That's always how it works. People get confused about pointers and not pointers and stuff because, you know, they think it's acting differently, when really it's not. It is only ever copying over the contents of what's in that memory address. What's in that variable. It depends on what's in that variable. If we're making a copy of a student, well, we'll have a copy of a student. We'll have two students, two independent students that represent the same thing, but they're different. They're in different chunks of RAM. Where here, I'm copying over the exact same memory location. So through either of these variables, when you dereference that memory address, you will get the one single student called, actually, it doesn't even have a name, but it'll be the Bob Smith 1, 2, 3, 4, 5, 7, 8, 9. This is the difference, and this is why in this situation, when we hit run, we see ABC twice, because whether I modify Bob Smith through the pointer held in A student or B student, doesn't matter. And look, I think, there. This is, turning them upside down is what I was basically doing by setting their name to ABC. I've made a change, but you'll see I've made a change. Both pointers are pointing to the one single student object that was changed. Oh, I thought I heard a boop, but I guess not. Will both of their names become ABC? Oh, yes, I did hear a boop, and yes, you're absolutely correct. Wait, no, that was your answer to a previous one. Never mind. Well, in this case, their names will both become ABC. And I guess it isn't a reference because it's a pointer, but whatever. Okay, test. Don't feel bad if you don't know this one. Ah, okay. So what's going on here? Well, here, what I've done is, basically I've now given a student, like Bob Smith, just another name that gets us to that, that is the exact same memory location. So when you modify it through either thing, it'll modify the same thing. But you have to understand that the pointers and references truly are, physically working completely different ways. It made a copy for us. So C++ seems cool, made a copy for us, but how did it know how to make a copy? Well, we have a very simple object so far. Our simple object, if we go look at the types inside of this object, like the attributes, the information stored in this object, they're just they're simple things. You know, it's a string, an int, an email address that's a string, and then a double. These are simple things. C++ is more than happy to, it can figure out how to make a copy of a string. It already knows that by default. It doesn't need special instructions. It doesn't need special instructions to copy over an integer either, or a double. It's easy. It knows how to do that. But as soon as the contents we're including here becomes a little bit more complicated, or I shouldn't say complicated, a little bit more complex, that's where we actually need to tell C++ how to make a copy of our custom objects that we're building. More on this when it becomes relevant. Yeah, okay, I just said that. Pointers, dynamic memory, etc. Okay. Now, we are going to define a copy constructor. If we go back to the code again, we have our constructor. This is our default one, where, you know, we just set default values that I made up, pulled out of thin air. We've got the other constructor, which takes the attributes or the parameters we want. And I mean, I can have as many versions of a constructor I want with different parameter lists. And I also have the deconstructor, which is the code to tell the computer, how do I actually delete this variable? Here, we will see that my deconstructor includes nothing. And it's because, again, these are all simple things. C++ knows how to go and delete these things. But imagine in here I had like a pointer to something else. And, you know, you're supposed to delete, like if I said, let's say, for example, I had an attribute in here called best friend. There. Bestie. Okay? So now, bestie is a new thing. But what is the type of this variable? It's actually like, it's supposed to be a pointer to a student object. So maybe in my default constructor, I have like, okay, bestie equals new student, and it'll just be a default student to start. Maybe I can change it later. I don't know. But here's the problem. I see a new keyword here. And you know that whenever you have a new, when you don't need it anymore, you got to delete it. We got to delete it. Otherwise, we get a memory leak. Now, if I were to go inside here in my main, and because these, really I should have this, delete a student, be student. And if I spell delete correctly, it'll work better. Okay, so delete a student, it's happy. Delete B student, it's happy. But we got a problem. Because when we call delete, it's gonna go and run the deconstructor. And there's no information in here right now. Because originally we didn't have anything sophisticated in here. But now we actually created a pointer to something else. This object created another student object and now has a pointer to it. If we delete this object, if we go here and delete a student and I don't delete this, suddenly this student object that we create, this thing that bestie points to, will still be in RAM somewhere. So although I deleted the thing that a student points to, bestie, the thing that points to, will still exist in memory. But there's a very simple solution to this. You go to your deconstructor and you say, okay, delete bestie. Done, problem solved. So when I call delete a student, the deconstructor gets called, and then what's the instructions? Oh, go delete the thing that, you know, bestie points to. There, solved. More on that again later, but going back to here, I'll get rid of bestie, don't need that anymore, and don't need that anymore. The next class we build will be, we'll have to do some of this stuff. All right. So anyways, like I was saying, default constructor, another constructor, and then a copy constructor. But a lot of times, although in this particular situation, C++ was comfortable to make a copy because it only contained very simple types and whatnot, there was no fancy pointers in there. But if I had something like a pointer, like if I make a copy of a student, and imagine for a second I still have that pointer to bestie, wherever that is. If I wanted to make a copy of a student, let me draw this out. If I am over here, so I have a student, okay? Bear with me because I'm going to have pointers with things that have pointers, okay? And we have the student object, okay? I'm just going to represent it as a very happy person. Now, bestie has a pointer to their best friend. This is bestie. And it's a pointer to another student object, right? So now to go back to the deconstructor, you can imagine if I deleted the thing that this pointed to, you know, suddenly this still exists. That's the problem. But anyways, when I make a copy of a student, how do I want to do it? do I want to do something like this? And have, you know, make a copy of the student. And then they're going to have the variable bestie that points to that same student. Should it go like this, or should I kind of like propagate the copying down? Should I also make a copy of the bestie? Or should it go like this? What do I want to do? Right? So hopefully you kind of see the question I'm asking is, when I make a copy of this object, okay, I make a copy of it, cool. But what do I do to the thing, like this object has a pointer to another object. Do I just copy the pointer over to that same object? Or do I want to also copy over the thing that this points to? And the answer to this question is, it's entirely up to you. This is where our copy constructors come in. Our copy constructors is where we define what it means to make a copy of a student object. In this particular example, it's entirely useless because the C++ would know what to do in this situation. It would completely know how to make a copy for us. No. What's going on here? None of my copies are working today. Okay. And then I'm going to go back. Oops, I guess. Here. And there. This right here is, remember before I was saying, oh, okay, we need the ampersand. This is the magic code. This is actually where I meant the magic code was. Whenever we're defining a copy constructor, it's going to be class name, const, class name, ampersand, and then whatever we want here. I've called it object. But the fact that you've got whatever the class name is here, it's student. So student, const, student, ampersand, and then the name of the variable. And then when we go back here, well, here's the actual code for it. Well, all I'm doing is this first name becomes equal to whatever the thing I'm making a copy of's first name is. And I'm just making a copy of all the contents. But you could see here, if I had that bestie, here's where I could write the code to tell C++ what it should do in that situation. Should it really just make a copy of the pointer and have it point to the same object? Maybe that's what we want. There is no like, oh, what's the rule? Should you do that or this? It depends on what you want to do. So this is where we actually get to tell C++. Is it going to be, and often we'll call these things shallow copies or deep copies. A shallow copy is one where we would only copy over the pointer and the pointer would be pointing to the same single thing. A deep copy would be one that keeps going and makes a copy of all the things down until there's no more things that we could copy. This, again, this is another thing that it took me a little while to wrap my head around. We're going to use it in this class, but try not to let this intimidate you because this is going to be something that you're just going to write, and its value in use isn't going to be that helpful until you need to use it. We will use it once we design the next class. But, and when I say class, I mean like object, not lecture. When we design the next class, which will be a management system for all the students, we will be able to, we'll see a use of this in a better way. I heard a question. Can we access properties with the object function name? What do you, so this is object first name. Oh, okay. Are you wondering because like, well, hold on. Why did I have first name and not get first name? Is that what you're wondering? Yes. Okay. The reason why is because we are actually, despite those things being private, all things of the same type could actually access the private things from other classes. Why? Because that's how it's written. That's how C++ works. I know it almost seems like, but then what was the point of making it private? Because private was to make it do, you're absolutely right. But this is how it works. So anything of the same type, because this is a student object, like this is the student class we're writing, we can access the private attributes from other student objects. Okay. So now when we call the copy constructor, oh, and here it is with pointers. Ah, yes, exactly, too. So if you want to call the copy constructor, with a regular old, like if you've got a variable with a student object inside of it, it'll know. But if you're doing it with pointers, you actually have to do, okay, it's a new student, but then you actually pass it the student object you want to make a copy of. And again, this is how we're going to do it most of the time. And let's see if we can prove to ourselves. Let's go back here. Let's see if we can prove to ourselves that on this line of code, we are actually running the code inside the copy constructor. Because I'm saying this right here, by calling student and giving it, you know, the memory, or not the memory address, because we dereference the memory address, by giving it the student object, it's calling the copy constructor. Let's verify this by doing like, there. My favorite form of testing, like, oh, did this code run and debugging, is because I'm super lazy, is just add a print statement in there. It's a bit of a meme where like, oh, your code's full of print statements. That's a bad debugging thing. Yeah, you're right, but I'm a bad programmer. So let's see what happens when this runs. I'm hoping we see I ran, because this right here should be calling the copy constructor. I ran. Awesome. So I know that copy constructor actually got called. The reason we didn't actually have to write it originally was because by default, C++ knows how to copy the strings and ints without any explicit instruction. Anyways. All right, okay, yeah, test copy constructor. Cool, copy constructor test if you don't believe me. Yeah, okay, we just did that. Yeah, okay. So headers, summary so far. Headers are where we say what the object will do and like what information it'll have. And the class files are where we actually write the code to say how it does what it does. Default constructors, constructors, copy constructors, and deconstructors are all super important special methods that objects have. Constructors are used to create the object. Copy constructors are used to create a new object based on another object. And deconstructors contain the instructions on how C++ should delete the object if it requires special instructions. ToString and equals are kind of important. In other programming languages, yes, they are super important, but in C++, I'm just making them important. I want to be very clear. And this is especially true if you came from the engineering side and you didn't take 161 with me. I threw a lot of information at you. A lot. And again, this stuff, I've taught you all this stuff and it has yet to kind of come back together. I know. You have there's a lot of open ends. The best way to learn this is to do it. So in the lab, we're going to be doing this stuff. And in the next object class we're writing, we're going to be using it more. But again, it won't click until you get a chance to use it. And in assignment 1, you're going to use it, which by the way, I hope you all saw I extended the deadline another week. So I hope you like that. Okay, we haven't really started. Oh yeah, and here's another point too. Like it or not, we also haven't really started the contents of 162. All we have done so far is review and kind of show you the nuances of C++. It was review of ifs, it was review of loops, types, variables, objects, and I do know, again, if you came from engineering, this is a new concept for you. But really, it's just been review. We haven't even started 162. We're already, what, 1/3 of the way through the semester? All right, in other words, have fun reviewing these slides a lot. Have fun watching this YouTube video a lot to just wrap your head around this weirdness. I know it sucks. It is what it is. Yeah, and we're only halfway done learning this stuff. So let's build a course class. We're gonna make another class that's gonna keep track of all the students in the course. So imagine like, I'm gonna make a student instance for all, how many people are here right now? All 29 of the students in this class. There should be like 8 more students here, but that's okay. I'm gonna make an instance of a student object for everyone here, but I need to manage them in some way. I mean, I'm gonna have 29 different variables holding all these things. That's gonna be a nightmare to keep track of. So I'm gonna make another class that is going to be the class kind of responsible for managing the student objects. and it's going to be called a course. And it's going to keep track of the students, keep track of the number of students in a class, and we're going to be allowed to add students to the course. I'm deliberately going to make this, albeit slightly more complex object. I'm still going to try to make it as simple as possible. This example here is going to be arguably the simplest form or the simplest example of what we call a collection. Yeah, okay. And this is what I want the student object to have. Remove students, print out students in the course. Okay, great. Which of these will be attributes and which will be behaviors? Well, keep track of students. That's probably going to be an attribute. Like I could probably store this in like an array. Keep track of the number of students. Okay, an integer. Add student to the course. That's going to be a method. Remove student method. Print out. Well, let's make that like a toString or something. Okay, so let's start our student object. Our student object, course object. There is a lot of weird stuff going on here. We're going to chew on this one at a time. Now, first include student.h. C++ is too dumb to know that if you start talking about something like student pointers, it's too dumb to know like, oh, but what's a student? Well, we have to say, okay, that class I just wrote, student, include this. You know about this. Oh, okay, fine. Down here, default capacity. What's going on here? We've got int array max int num students. Why do we, okay, array max num students. This seems like it might be holding on to the same thing. And then suddenly we have this dreaded thing that I was like hinting about for the last couple of weeks about having a student pointer. What the heck is going on? And then here, I mean, under private, we see these attributes, which we're used to. But what's going on here? This is a function, right? Its return type is void. It's called expand capacity. It's got the parentheses. We've got this private function. What use could a private function be? Okay, we've got our default constructor, our not default constructor, a copy constructor, deconstructor. Okay, fine. That's fine. That's reasonable. And I guess here I'm defining, okay, adds a student. Well, I guess it's going to take the information it needs to make a student object and then add it. Remove a student based on a student number, clear the course, get number of students, toString. Okay, that part's not too crazy, but we're going to take our time and do this. We're going to attack this one chunk at a time. First thing I'm going to do is copy all this. I'm going to go over to my Visual Studio, right click on class, add class. And what did I call it? A course. So I'm creating a course object and I'm going to say okay, and this is going to automatically create my header and C++ files and put them in the proper places in the project. Give it a second. There. So now we see we have course header and course CPP. Course header, I'm just going to replace it with all the stuff that was on that slide. So I'm going to need to, do all this. And you also might see something funny here. Earlier I was saying like, well, in our in the header, we only really want to declare what the variables are going to be, like here, int array max. But here, not only have I declared it, I actually assigned it a value. So that seems like I'm kind of breaking my rule. Well, we can do this, and you'll notice it's also a constant. So this default capacity is just set, and it's not going to change. Where is this going to come up? You'll see in a moment. But other than that, I guess, other than the weirdness that we saw, I guess, okay, this is where we are. Okay, yeah. Okay, so I just threw a whole header at you. We're going to make everything fall into place as we go. Now, we're going to have to start writing the code to make it do what it needs to do. So, here. This is my course.cpp file. We're going to start here. Course CPP. There's nothing here. This is normal. I mean, it's got the include header, which we need because it basically copies all this and puts it at the top, and it's just declaring everything. It's letting it know, okay, here's all the things you're going to do and whatnot. So we'll start with the constructors. I always really like to start with the constructors, and it's probably good to write a default constructor first. And here's our default constructor. I'm going to copy the code, put it in here, and let's see what is going on. Well, okay, from course, the header, and this is our like namespace. the name of the class, so it's a constructor, and its default, it's not taking any attributes. Open. Okay, so this is only stuff here going on. What are we going to do? How do we set this up? Well, by default, if I ever create a course object, I'm going to have it be empty. Okay? I am going to take my number of students variable that holds on to the number of students currently in the course. And its value is going to be 0 because, it's going to start empty. I'm going to have no students in my course. Then I'm going to I've got my class variable, which is, what is that again? My class is a student pointer. What on earth is going on? Well, okay, my class is a pointer to a pointer of student. So, okay, what am I putting here? New student star. Okay. So, what's going on here? So I'm creating a new something in dynamic memory. What is this? Okay, well, I look at this and I know that, I'm creating a student pointer, and we see these square brackets. I'm creating a student pointer array. And then I'm setting the array max to default capacity. Okay, so I guess when I create the student pointer array, the value in here is going to be whatever the default capacity was, which is a constant, which I guess is 10. Why? Because I made it 10. And if you're wondering then, is it, if the capacity is 10, if you've made an array of size 10, how on earth are you going to, what if your class has 11 students in it? Well, more on that to come. And I don't think we'll get to that today, which is too bad because it's really fun and exciting. But this is our current situation. Now, you're probably wondering about this. I know you are, but one second. So default capacity is used here. Okay, we make an array of the size, default size, and we start with no students inside of it. Here I'm using an array of pointers to person objects. Oh, not persons, students. That should say students. I could use an array of persons. This should say students, not persons. I think I used persons last semester also. But this would have some funny implications. So let me see. Okay, I'll get this blank. And let's just draw out what we have. We have my class, okay? And the thing that has to be in here is the memory address of memory addresses that get us to students. So we've got this. But we know that this actually right here is a student pointer array. So we've got an array where the contents of this array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. It's the default capacity and everything. But I know that the stuff in this is pointers to student objects, right? So this is where we have pointers to pointers, because I know a lot of people were thinking well, where the hell would I ever use that? That seems crazy. Well, here's a perfect example of it. We have pointers to the array that gets us to a point, that is a pointer to a student object. It is not an array of student objects. Sad, because that's not the case. This is not what it is. It's not. It's a pointer to an array of pointers to student objects. And we're going to do it this way, and it'll come together soon. I know I sound like a broken record. I've said that a lot. We are really getting into the thick of the, okay, wait, what the hell? We are broadening things. It's going to come together shortly. And I think coming together is going to have to wait until, sadly, it's going to have to wait until Friday. But those of you that have lab on Thursday, you might be thrown in a little bit into the deep end. Why is the star on the right of the student? Well, that's because, remember, when the star is on the left of a variable that gets us to a student, that's a pointer to a student, that's dereference. But when the star is next to the type on the right side, that means it's like a pointer. That means we're declaring something where the type is a student pointer. So when the star is on the type in the right-hand side, like you said, that's the modification to the type. It's not a student, it's a student pointer. So if we look back at that array, it says like student star square brackets, that means it's like, what's the type of that array? Student star, student pointers. Anyways, for those of you that have Lab Thursday, you might be thrown in the deep end a little bit on this, but I don't think it'll be too bad. I mean, we'll work through it together. But those of you on Friday will probably have a little bit of an easier time with the lab. But anyways, I'll see you all on Friday at the very least, and half of you tomorrow. When will A2 open? Probably immediately after. I'll probably make it available, because when did I make it? I moved the deadline back to like the 15th, I think, right? Yeah, the 15th. Assignment 1 is due on the 15th. I'm probably going to post assignment 2 like on the 15th and make it due on March 1st. Thank you. Yeah, no problemo. Suppose I could, if I'm feeling nice, maybe I'll post it early just for those of you that really want to get a head start. But I do find that that does end up really stressing a lot of students out, so we'll see. Anyways, enjoy the rest of your day. I'll see y'all later.